Welcome to our student. Now I am going to discuss about the JAM question solution 2023 regarding the organic chemistry that will be helpful for NEET and JEE guidelines. Now if we go to that of the different type of problems coming to the 2022, that is the first problem is that of the nucleophilic substitution reactions in presence of the sodium cyanide in the acetone solvent, and second problem is that of the NMR problems, and third is that of the elimination related problems, and fourth is the rearrangement problems. If we go to that of the first problem, we first going to that of the NGP. What is the NGP substrate? In case of the NGP substrate, the phenyl group is participated in the neighboring group participation reactions by the pi electron and produces the a 3-member cyclic intermediate 51, and then the nucleophilic substitution to give that of the retention configuration of product. But in presence of the solvent, the SN2 reaction can also take place. From this observation, it can be shows that the retention of configuration take place in presence of the nucleophile, different type of the leukophile, or SN2 reaction take place. But retention of configuration take place in presence of NGP reaction, but inversion reaction take place in presence of the SN2 reaction. If we compare the data K delta by Ks, in case of the K delta means the participation of the substrate in the NGP reaction, Ks means participation of the substrate in the SN2 reaction. If we see that of the different substituents in the aromatic rings, in presence of the strongly electron donating groups, the NGP reaction is more faster compared to that of the SN2 reaction. In presence of the methyl group, similarly the NGP reaction is faster than that of the SN2 reaction. But in case of the chlorine group, in presence of the chlorine, the SN2 reaction is more faster compared to that of the NGP reaction. That is, the inversion of product will be formed rather than that of the retention of product. Similarly, the solvent can also affected the NGP reaction as well as the SN2 reaction. In case of the solvent, different type of the solvents are used for the substitution type of reactions. In presence of the acetic acid, formic acid, in case of acetic acid, the NGP reaction is 35 to 38%, but in case of the formic acid, that becomes increased. That is, with increasing the polarity as well as with increasing the nucleophilicity of the substrate, the NGP reaction is more favorable compared to that of the substitution reaction, that is the SN2 reaction. The given problem is that of the substitution with that of the NGP, that is the NGP versus SN2 reaction. In case of the NGP versus SN2 reaction, if we see that of the substrate, the nucleophile can attack to that of the inversion product to get that of the 3O product, that is the hydrogen present in the opposite sides. But if we see that of the NGP reaction, in case of the NGP reaction, the substrate will, that is the phenyl and the OTS group participate in the NGP reaction, so it must be present in the anti-periplanar orientation. For the regions even number exchange, after the even number exchange, the phenyl group is participated in the NGP reaction and it gives to that of the 3O product. But in SN2 reaction, we get that of the 3O product. That is, the SN2 reaction gives the inversion product, but NGP reaction gives that of the retention product. But here, the nucleophile is very important for that reaction. The acetic acid take part in the NGP reaction as in presence of the acetic acid, instead of the sodium cyanide, the NGP reaction is more favorable. But in case of the sodium cyanide, the nucleophilicity of the Cn- is very large, so it readily take part in the SN2 reaction and to get that of the 3O product instead of that with the erythro product. So the option C is the correct for that questions. Now, if we go to that of the NMR spectroscopy, in the NMR spectroscopy, we know that the nuclear magnetic resonance spectroscopy, it is very important for that of the different type of the structure and determinations. And from that of the chemical shift parameter, it has been shows that the different type of the protons resonate at different regions. That is, this is the regions for that of the alkane protons, and this is the region for the next to oxygen. That is the 3.0 to 4.5 ppm, and the proton containing to the unsaturated alkenes resonate at 4.5 to 6.5 regions, and the proton at the aromatic regions resonate at 6.5 to 8.5 region, and these protons resonate, the aldehyde proton and the carboxylic acidic proton resonate at that regions. And this is the representative examples for that of the different type of the substituted aromatic rings, where the chemical shift gives that of the different type of the signal. Here that four A, B, C, D means the four type of signal is arises, and this four type of signal and the para-substituted compounds always gives that of the doublet and doublet signal for that regions in the aromatic regions. And the aldehyde proton for the different type of compound, the aldehyde proton always resonate at 10.14 ppm and 9.0 ppm and 8.01 ppm. That this is the shielded proton compared with two compounds, because the stronger resonance effect on the nitrogen lone pair by the aldehyde group, lowering the chemical shift value. Hence, the given problem, an organic compound having the molecular formula C9H10O2, that characteristic proton, that is the 9.72, this must be come to that of the aldehyde proton, and this is the 7.1, 6.7 is the aromatic region proton, and the two protons are doublet and doublet, so it must be para-substituted, and 3.8 singlet 3H means this proton is the methoxy proton, and 3.6 doublet 2H, this proton is the adjacent to that of the carbonyl group and the phenyl group. So the correct structure is that the para-substituted phenyl acetaldehyde, methoxy substituted phenyl acetaldehyde is the correct structure. Now go to that of the elimination reaction. What is the elimination reaction? We know that the elimination reaction is that of the Sergev and the Hofmann elimination. We know that. In case of the Sergev elimination, we get that of the more substituted alkenes, but in case of the Hofmann elimination, we always get that of the less substituted alkenes. Here, the more substituted alkene is formed, that is this product is the product-like transition state according to that of the Hammond postulate, and this is the reactant-like transition state as the mono, that is the less substituted alkene is formed. This is the Hofmann type of reaction. Here, in this problem, the NOH, the bromine group is eliminated from that system, and the stereoelectron requirement for the E2 elimination is that the two leading group must be present in the anti-periplanar orientation, and from that substrate it has been shows that the two eliminating groups, here the hydrogen and bromine, come to that of the anti-position, and we get the elimination product, and we get that of the, this is the trans product, means this is the 1 and this is 2 pyruvatic sequence, and phenyl group is also 1, and here is the hydrogen is the 2, so the 1 group is the opposite side, so this is the anti-product. Similarly, other isomer gives that of the 3O product via the anti-elimination, so E2 elimination is the stereo-specific elimination reactions, and hence the given problem is that the major product formed in the reaction of 2S3R 2-chloro-3-phenyl butanol with sodium methoxide in ethanol. The substrate is that of the erythro substrate. Here the 2S means this chlorine group is the 1 and this group is the 2 and this is the 3 and this is the 4. So 1, 2, 3, this is the clockwise rotation, and clockwise rotation it should be it should be S. So this is the 2S and this is the 2,3R configuration. And from that, if we convert it to that of the Newman projection, and after the Newman projection, after elimination, it gives that of the Z-phenyl butene. Here the hydrogen and the chlorine group must be present in the anti-peripheral orientation, and the stereoelectron requirement is maintained, and we get that of the Z-phenyl 2-phenyl butene as the product. Now, I am going to that of the Favorsky rearrangement problem. In the Favorsky rearrangement, we know that the alpha bromo substituted ketone undergoes a rearrangement reaction in presence of base or in presence of sodium methoxide via the cyclopropanone intermediate, and to give that of the ester or carboxylic acid. Here, the given problem is that the methoxy group is deprotonated, the carboanion is formed, and after that the cyclopropanone intermediate is formed, and after the cleavage of this cyclopropanone intermediate and followed by the elimination of the Br group, we get that of the alpha beta unsaturated ester compound. So the option C is the correct. And hence, the in case evidence of the KU is the similar type of problem, the cyclopropanone intermediate is formed, and after cleavage it gives that of the carboxylic acid derivatives. But here the interesting is that here the alpha hydrogen is absent, so in presence of the OH minus, the carbonyl group directly attacked by the OH minus, and after the alkyl migration we get that of the carboxylic acid. Here the cyclopropanone intermediate is not formed due to the absence of the alpha hydrogen atoms. Now this is going to that of the one other interesting problem that was taken from that of the Clayton books, and different type of problem is given here there, and one is that fragmentation reaction. Here the fragmentation reaction is that the two group is eliminated and we get that of the different type of the fragmented product. Here the OH groups is eliminated, and to give the alpha beta unsaturated aldehyde product, alpha beta unsaturated substituted alkene substituted aldehyde product, and similarly the Bergman rearrangement. Here Bergman rearrangement is not occurs, rather the CH group is cleaved and to give that of the cyano-substituted product. This was came in the JAM examination, and this is very important problem. And now in the next video I will discuss about this problem, and this will be continued. Thank you.